F322 Naming Alkanes tutorial. So this video will explain how to name some simple alkanes and take you through some worked examples. So an alkane is the simplest series of hydrocarbons. It's got no double bonds and no other functional groups. And the name of an alkane is split into three parts. So if we just look at an example, so there's the name of a simple alkane, methyl propane, and as I said, the name is split into three parts. The suffix, which comes at the end of the name, for the case of alkanes, the suffix is always ane. The suffix tells you which series the compound is, or which functional groups it's got. So all alkanes will be the same, and they'll have the suffix ane. The stem, which is the middle part of the name, in this case prop. Now this tells you how many carbons you've got in the longest carbon chain. So it will have a different stem depending on how many carbons are in the longest chain. Now prop means 3, so this tells us that in this molecule we've got a longest carbon chain of 3 carbons. The prefix, which is the bit at the start of the name, in this case methyl, this tells us any other key information that we need to know about this molecule. It tells us whether we've got any substituents that are branched off from the longest carbon chain, or it might tell us if the alkane is a cyclic compound. So let's look at a few examples. Okay, now don't forget to pause the video at any time if you'd like to have a go at naming some of these examples for yourself. So here we have simple alkane. We know it's an alkane because there's no double bonds, there's no other functional groups. So straight away we know that the suffix is going to be ane. The next thing we do is look for the longest carbon chain. So as you can see here, we've got a chain of 1, 2, 3 carbons. The stem for 3 is prop, so this alkane is simply called propane. In this example, they've shown us the skeletal formula, which doesn't show the hydrogens in the molecule. It doesn't matter, we'll still name it in exactly the same way. So again, we can see that it's an alkane, so we start with the suffix ane. This time, the longest carbon chain is 1, 2, 3, 4, 5, 6 carbons. The stem for 6 is hex. So this alkane will simply be called hexane. Okay, again here we've got another skeletal formula. Longest carbon chain this time is 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. The stem for 9 is non. So this molecule will simply be called non-ane. Now the 3 examples we've looked at so far don't contain any branches coming off from the longest carbon chain. They're just simple alkanes. So let's look at some examples where we've got branches as well, and so we need to include a prefix onto the start of the name. Okay. So again, we've got a skeletal formula here. Longest carbon chain is 1, 2, 3, 4, 5 carbons. The stem for 5 carbons is pent. So this alkane will be called pentane. However, as you can see, we've got another carbon here, which is branched off from the second carbon in the longest chain. We call this an alkyl group. And again, when we're naming these alkyl groups, we use a similar stem to the one we've used here. So if the branch consists of one carbon, which in this case it does, the stem will be meth, and all we do is replace the alk in alkyl with the stem. So this will be a methyl group attached to the second carbon. So we'll include this information in the stem, sorry, in the prefix. So we've got a methyl group, so it will become methyl pentane, and the methyl group is attached to the second carbon. So to show this, we put a 2 before the methyl. So this alkane will be called 2-methyl pentane. In this example, we've got a structural formula rather than a displayed or a skeletal formula. Now, I always find it easier when naming these sorts of compounds is to draw them out as a displayed formula before we name them. So this CH3 here tells us that we've got a C with 3 hydrogens attached. We've then got a CH group next to that. Now this CH3 being in brackets, that tells us that that is a branch attached to this carbon. So we've got a CH3 group branched off from this carbon. And then finally, we've got a CH3 group on the end of the molecule. So now we've drawn it out like this, it's a bit easier to see what's attached to what and see what the longest carbon chain is. So as you can see here, longest carbon chain is 1, 2, 3 carbons. The stem for 3 is prop, so we know that this name is going to include propane at the end. And again, we've got another branch attached to the second carbon in the chain. Again, it's an alkyl branch consisting of just one carbon, so it's a methyl branch. Now, in the previous example, we put a 2 before that to show that this carbon is attached to the second carbon in the chain. In this case, we don't need to do that. Because the longest carbon chain is only 3 carbons, this methyl group couldn't be attached to any other carbon. If it was attached to carbon 1 or carbon 3, it would become part of the longest chain, and then the stem would change, and it would be butane instead of propane. So because this is the only carbon that the branch can be attached to, we don't need to include that in the name. So this name will simply be methyl propane. In this next example, here we can see the longest carbon chain is 1, 2, 3, 4, 5, 6, 7, 8 carbons. The stem for 8 is oct, so we're going to use octane as the final part of the name. Now again, as you can see, we've got another branch here. Now this time, it's an alkyl branch, but it contains 1, 2 carbons. So instead of a methyl branch, this is now an ethyl branch. It's attached to the 4th carbon in the longest chain, so it will become 4-ethyl. Therefore, the name of this alkane will simply be 4-ethyl octane. Okay, so in this example, as you can see again, we've got 3 branches attached to the longest carbon chain. However, don't just assume that the longest carbon chain is just going to go from left to right. In this case, 1, 2, 3, 4, 5, 6 carbons. If that were the case, we'd have a methyl, and a propyl group attached. However, 6 carbons is not the longest carbon chain. We've actually got a longer chain going from here to here, which is 1, 2, 3, 4, 5, 6, 7 carbons. So if we've got a longest chain of 7, the stem that we will use is hept. So this will be heptane. We then deal with the branches. So we've got a methyl group here attached to the second carbon. We've got a methyl group here attached to the third carbon. And we've got an ethyl group here attached to the fourth carbon. Again, remember to number the longest carbon chain so that it gives the branches the lowest possible number. Two methyl groups will become dimethyl. And again, because E is before M in the alphabet, we will list that first. So this alkane will be 4-ethyl, 2,3-dimethyl heptane. Okay, all of the examples that we've looked at so far have been straight chain or branched alkanes. The next couple of examples that we'll look at are examples of cyclic alkanes, which means that the longest carbon chain is not arranged in a straight line, but they're actually joined together in a ring. So when we're working out which stem we're going to use, instead of looking at the longest carbon chain, we're going to look at how many carbons are in the ring. So for example, in this first alkane here, we've got a ring containing 1, 2, 3 carbons. So the stem for 3 will be prop. So this example is going to be propane. Now, because it's a cyclic alkane and the carbons are arranged in a ring, we add the prefix cyclo. So the full name for this alkane will be cyclopropane. In the second example, here we've got 1, 2, 3, 4, 5, 6 carbons in the ring. The stem for 6 is hex, so we'll use hexane. And again, because it's a cyclic alkane, this will become cyclohexane. In this next example, here you can see that we've got 1, 2, 3, 4, 5, 6 carbons in the ring. However, now you can see that we've got a branch as well. Now, if you've got a branch, always start numbering from the carbon where the branch is. So we've got 1, 2, 3, 4, 5, 6 carbons in the longest chain. Remember, the stem for 6 is hex, so it will be hexane. And because it's cyclic, we've got cyclohexane. As you can see here, we've got a methyl group attached to carbon number 1. However, because we could have started naming from any of these carbons in the ring, it wouldn't have made a difference. So we don't need to number the methyl group. So this compound will simply be methyl cyclohexane. As you can see here, we've got a cyclic alkane which has 2 alkyl branches. So we start numbering the carbons in the ring, making sure that we give the branches the lowest number possible. So we'll start from here as carbon 1. So that's 1, 2, 3, 4, 5. The stem for 5 carbons is pent. And again, because it's cyclic, we'll add the prefix cyclo. So we've got cyclopentane. We've also got a methyl and an ethyl branch, and both of these are attached to the first carbon. So these are 1 methyl and 1 ethyl groups. When you've got more than one substituent, you always have to number which carbons those are attached to. And again, we list them alphabetically. So the name for this alkane will become 1-ethyl, 1-methyl cyclopentane. The last cyclic example that we're going to look at is this one, which has two alkyl substituents or alkyl branches, but this time they're attached to different carbons. So now we don't know whether to number from this carbon as carbon 1 or this one. Now, because this branch is bigger, this is an ethyl group, whereas this one's a methyl group, we give the longer chain the smaller number. So this one will be carbon 1. Now, if we numbered this way round, so 1, 2, 3, 4, 5, that methyl group will be attached to carbon 5, whereas if we numbered this way, 1, 2, 3, this methyl group will be attached to carbon 3. Obviously, 3 is a lower number than 5, so we will go anti-clockwise. So 1, 2, 3, 4, 5, 6 carbons in the ring. So this will be cyclohexane. And as you can see, we've got the ethyl on carbon 1, and we've got the methyl on carbon 3. So if we put all this together, again remembering to list alphabetically first, we've got 1-ethyl, 3-methyl cyclohexane. The final set of alkanes that we're going to look at are halogenoalkanes or haloalkanes, which basically means that instead of an alkyl group attached to the longest carbon chain, you've got a halogen. We name them in exactly the same way as we have been doing. The only difference is that when it comes to naming the branches, we'll give it a slightly different prefix. So whereas we name alkyl groups methyl, ethyl, propyl, etc., we would name these chloro, bromo, fluoro, or iodo, depending on what the halogen is. So in this example, as you can see, we've got a longest carbon chain of 1, 2, 3 carbons. The stem for 3 is prop. So this alkane will be propane. We've then got a chloro group attached to the second carbon. So in exactly the same way as we have been doing, we use this as the prefix, and the full name will become 2-chloropropane. In this example, as you can see, we've got two halogens. Now both of them are on the right-hand side of the molecule, so we number the longest carbon chain from the right-hand side so as to give these two groups the lowest number possible. So we've got 1, 2, 3, 4, 5 carbons in the longest chain. The stem for 5 is pent, so this will become pentane. Now we've got two halogens. We've got a chloro group attached to the first carbon, so that will be 1-chloro. We've also got a fluoro group attached to the second carbon, so that's 2-fluoro. And again, remembering that we list the branches or substituents in alphabetical order. So C comes before F in the alphabet. So the full name for this compound will be 1-chloro, 2-fluoropentane. In this example, again, we've got a structural formula rather than a skeletal or displayed. So let's draw it out as a displayed formula. So we've got a CH3 group on this end. That's attached to a CH group. We've then got a bromine also attached to this carbon, which is a bromo group. That's attached to a CH2. And so this second bromo group will be on this end. Now it's much easier to name, as we can see exactly which substituents are attached to which carbons. So again, we've got a longest carbon chain of 3. We'll number from the right hand side to give the 2 bromo substituents the lowest number possible. So that's 1, 2, 3 carbons in the chain. Stem for 3 again is prop, so that will be propane. The 2 bromo groups are attached to the first carbon and the second carbon. Now remember, if we've got 2 groups of the same type, in this case it's bromo, we use di to show that we've got 2 of them. So this will become 1,2-dibromopropane. So the final example that we're going to look at is this one here. And as you can see, this has got both halogens and alkyl substituents attached. That doesn't make a difference when we're naming it. We still use exactly the same process as we've done all along. So here you can see the longest carbon chain is 1, 2, 3 carbons. So again, we'll use propane as the stem and the suffix. Now we've got 3 different substituents. We've got a chloro group which is attached to the first carbon. So we've got 1 chloro. We've got a methyl group attached to the second carbon, which is 2 methyl. And we've got another methyl group attached to the second carbon, so we've got another 2 methyl group. Remember, if we've got 2 substituents that are the same, we would use di, so this will become 2,2-dimethyl. And again, we list the substituents in alphabetical order. So C comes before M. So the full name for this final alkane will be 1-chloro 2,2-dimethyl propane.